So we're going to go into how to read a solubility curve. So to make this a little more obvious, I'm going to change X and Y to different colors. We've got orange and purple now. Y is purple, X is orange. So what this line is showing you is the absolute maximum amount of solute that can be in a certain amount of solvent at different temperatures. So on our x-axis we have temperatures, and it's increasing as we move in standard reading order. So here is 0 degrees all the way up to 100. And the way it works, make it more clear. There we go. They're not quite lined up. So what that means is that at 10 degrees Celsius, we're done using Kelvin, substance X can hold exactly this much solute if I'm using 10 milliliters of solvent. We'll come to that in a minute because it's not always going to be based on tens. Now what happens if I increase the temperature? I go from 10 to, let's say, 50. The amount of solute that I can hold increases to here. So at 10 degrees I could hold approximately, let's say, 1.8 grams. At 50 degrees now I can hold, that's closer to 13.4 grams. And you can see that if I continue to increase temperature, the amount of solute that I can dissolve will increase. At this point, when I reach 100 degrees Celsius, the amount of solute I can hold is above 30 because that's where this graph maxes out. Now if we switch over to substance Y, over to purple, if we start at, let's say, 20 degrees Celsius, I can hold 3 grams solute per 10 milliliters of solvent. If I increase that to 80 degrees Celsius, now I can hold 9 grams of solute. I haven't changed the amount of solvent. I still only have 10 milliliters in each case. However, I can increase my temperature, I increase that kinetic energy at the molecular level, and it will dissolve more. It will hold on to more of that solute. Now, that describes a saturated solution. When I have exactly the maximum amount of solvent and solute, that is saturated. So if it is found right on this line, that solution would be described as saturated. Let's say at 80 degrees Celsius I have only 5 grams. This would be unsaturated because I can still fit more solvent in there. Solute, my bad. There's still more space. And then if I take, let's say, 15 grams and I add it to 10 milliliters of solvent, not all of it will dissolve. This is a supersaturated solution. Because at 80 degrees, I can only hold 9 grams of solute. If I try to put in 15, now I have a supersaturated solution. These remaining 6 grams will not dissolve. They form a precipitate. You can put them into suspension by shaking it, but they will not move into solution. So when you're looking at these solubility graphs, if the amount of solute you have is above the line, it is supersaturated. If it's below the line, it's unsaturated. And if it's perfectly on this line, then it is saturated. That is a multiple choice skill you're going to have to know how to answer. And that's not just for, in this case, substance Y. It applies to any solubility curve. It doesn't matter what substance X is. If I give you a question and let's say at 30 degrees Celsius, right here, I have 14 grams of solute. So I'd move up to 14. Boom. It is above this line, which means this is a supersaturated solution. We'll put supersat for short. If I were to mix it up a little and say that, okay, at 30 degrees Celsius, now I only have 1 gram. I am now below this line of saturation, so I am unsaturated. Unsat for short. Now, all of this is assuming 10 milliliters of solvent. Well, what if I doubled my solvent? Let me clean this up a little. Instead of 10 milliliters, oh no, what I really meant was 20 milliliters. What happens is I take the amount that would fit in 10 and I just double it. So on your assignment, you have a question that says, like, I think it's how much would fit in 250 milliliters. You take the total amount of solvent I give you, so total solvent, and you're going to divide that by the amount of solvent on your table. So we'll call it table solvent. So if we use that example I just made where I want 20 milliliters, it would be 20 milliliters divided by 10 milliliters, which gives me 2, which means I'm going to multiply any amount of grams that I figure out on my y-axis, multiply by 2, and that will tell me. So if I do remember correctly and it's 250 milliliters, my table is based on 10. So if I divide, I'm going to multiply everything by 25. So if I'm looking at substance Y again, at 40 degrees Celsius, 40 degrees Celsius, normally my saturation point would be right here, and that would be 5 grams. But if I have 5 grams at 10 milliliters, at 250 milliliters, I would multiply by 25. So that 5 times 25 would be 125 grams. That would give me a saturated solution. So you're going to do an introductory assignment on solubility graph interpretation, and we'll move more into this next week.